Okay, let's continue with question 5, and let's read this together. All right, so it says, Kate buys 5 books and 8 CDs at the library book sale. The books cost $4 each, and the CDs cost $3 each. Which equations can be used to find how much money, and we're going to use S for that, Kate spends at the library book sale? Choose all the correct answer. So again, it's one of those choose all. So we're going to go through each and every one of these and figure out which ones are correct. All right, so I broke it down. So again, to figure out how much she spends in all, we have to add the amount she spent on the books and the amount she spent on CDs. Now, according to the problem, she buys 5 books. And if I just skip this for a second, the books cost $4 each. So I wrote that here. She has 5 books and she spent $4 on each book. And then for the CDs, she bought 8 of them and she spent $3 on each CD. So again, 8 CDs at $3 a piece. So if we have 5 books at $4 each, we're going to group the books together in a parentheses, and we're going to go 5 books times $4. All right, and then we're going to add that to the 8 CDs at $3 each. So again, we're going to group this in parentheses. 8 CDs times $3 each. Okay, and of course, that is going to equal our S. Now, we can solve this, but that's not what the problem is asking for. But if you're curious, it would be 20 plus, 8 times 3 is 24. So the total, 20 plus 24, would equal 44. But anyway, we don't really need to know that to answer this question, but in case you're wondering, she spent 44 bucks. So now what we're going to do, and I'm going to just erase this so that we're not confused. We're just going to look at this equation, and again, we're going to go back and we're going to choose all the questions that are the equations that look like it here. Let me put that up. All right. So let's look at A, and it says S equals 5 times 8 plus 4 times 3. Well, if I'm looking here, we did 5 times 4 and 8 plus 3. So this doesn't make sense. It's not correct, so we're going to cross that out. Letter B. S equals 8 times 3 plus 5 times 4. Well, that looks a lot like what we came up with. They just took the 8 times 3 and put it over here, and the 5 times 4 and put it over here. So yeah, that would work, because when we're adding, we can switch up our numbers. So B is correct. Let's look at C. C is 5 plus 4 times 4 plus 3. Well, again, if you look closely, we didn't add 5 plus 4. We multiplied 5 times 4, and we didn't add 4 plus 3. As a matter of fact, it's not even 4 in the parentheses, it's 8. 8 is supposed to be in parentheses, so this is not correct at all. All right, and again, let's look at this one. S equals 5 plus 8 times 4 plus 3. And again, we're not adding inside these parentheses, we're multiplying, and we're not multiplying these two together, we're adding. So this, again, does not make sense. Let's look at this last one. S equals 4 times 5 plus 3 times 8. Well, this does look like what we did. All they did was we took the 4 and the 5, or the 5 and the 4, and we turned them around. We can switch these around, because when we multiply, you can do the turnaround effect. So yeah, 4 times 5 is the same as 5 times 4. And also here, 8 times 3 is the same as 3 times 8. And we are adding them. So yes, this one makes sense. All right, let's look at number 6. It's asking you, What are two ways you can describe the pattern below? Well, for one, they go back and forth between triangles and circles. So triangle, circle, triangle, circle, triangle, circle. And you can see it is a pattern because it repeats itself 3 times, right? Triangle, circle, triangle, circle, triangle, circle. So yeah, the pattern is they go back and forth between triangles and circles. And another way to describe it is by odd-numbered spots and even-numbered spots. Let me zoom in here. All right, so if this is spot number 1, spot number 2, 3, 4. I'm just numbering the spots. This is the 5th spot. This is the 6th spot. The odd number spots have an odd number of sides because triangles have 3 sides. So yeah, 3 sides, 3 sides, 3 sides. And the even number spots, well, those are circles. All right, so again, this is just another way to describe this pattern here. All right, number 7. All right, so we got to decide if each of these are prime or composite. So we've got to look at 3, decide if 3 is a prime or composite number, 8, prime or composite, and so on and so on. So to do that, we need to figure out factor pairs. And again, prime is only one factor pair. And composite is more than one factor pair. More than one factor pair. All right, so I'm going to do the factor pairs here on the side just to show you all the factor pairs. So with the number 3, we start with the automatic, which is 1 and 3. And if we go down our multiplication chart, I use a multiplication chart to help us with factors. So 1 and 3. 2 is not a factor of 3 because we can go 2, 4. And so that's not a factor. But 3, of course, is, right? So that, my friends, is a prime number because it only has the factor pair 1 and 3. All right. Out of focus. Sorry about that. Okay. Let's look at 8. So again, the automatic factor pair is 1 in itself. So 1 and 8. And if I go across my multiplication chart, so we did 1 and 8. 2, if I go across the 2's, I do C and 8. So that means 2 and 4. So 2 and 4 is another factor pair because we see 8 here. And then we could go through and do them all. 3, and there's no 8's there. And 4, we hit our turnaround fact. So that means we found all our factor pairs. So 8 is a composite number. All right. Number 9. Well, the automatic is 1 and 9. So again, 1 in itself is the automatic factor pair. And if I keep going, 2, I don't see 9 here. 3, 3 times 3 is 9. So 3 is another factor. So again, and that's our turnaround fact. So again, because it has more than one factor pair, it is composite. All right, 17. All right. Well, again, we start with our automatic factor pair, 1 and 17. And I'm going to go through all these numbers and see if we see 17. If I go 2, I go across, I don't see 17. 3, I see 12, 15, no 17. 4, nope. 5, no 17. 6, no 17. 7, no 17. 8, 9, there's no 17s here. 10, 11, 12, 13, no 17s, no 17s, no 17s. It is a prime number because the only factor pair is 1 and 17. All right. Last one is 18. So again, we start with our automatic factor pair, 1 and 18. If I go across the 2's, I'm looking for 18. Yep. 2 times 9 is 18. So I'm going to put a comma here. I'm going to go 2 and 9. Put a comma here. All right. 3's, 3 times 6. 3 times 6. So we got 3 and 6. 4, no 18 there, 5, no 18, 6, and 3. Well, we hit our turnaround fact. So definitely composite. Now, we could have stopped. I mean, if you wanted a shortcut, once you found a second factor pair, like we know how we went and we saw 1 in 18, that's the automatic, and then once we saw another factor pair, we could have stopped. And we don't have to find all the factor pairs to determine if it's composite, because the minute it has a second factor pair, it's automatically composite. So anyway, just a heads up on that. All right, number 8. Start with the number 3, use the rule multiply by 3, and write the next 3 numbers in the pattern. And show your work. Okay, hold on a second. All right, so we're going to start with 3, and we're going to multiply by 3. And that equals 9. Okay, so that would be the next 3 numbers. So the first number in our pattern is 3. Our second number is 9. Then we're going to take this 9, put it over here. 9 times 3 is 27. Okay, and so 27 is the next one in our pattern. And 27 times 3. Well, I'm just going to give you the answer on that. You would have to probably work that out, use some partial products or something like that, but I'm just going to give you it. It's 81. Okay. All right. On Sunday, Pablo bikes 7 miles in the morning. He bikes 5 times as many in the afternoon. How many miles does Pablo bike in all on Sunday? So this is where a lot of 4th graders tend to make a mistake with this question. The question is tricky. How many miles does Pablo bike in all on Sunday? So to figure that out, we're going to have to add the morning plus the afternoon. A lot of times, what 4th graders like to do is just do the 5 times as many in the afternoon and give that as an answer. But no, we need to know how many miles he bikes in all on Sunday. All right, so to do this, we're going to do morning, and I'm going to do a bar model, and then I'm going to do afternoon. So in the morning, he bikes 7 miles. And it says it right here. It gives it to us. 7 miles in the morning. And he bikes 5 times as many in the afternoon. So I'm going to do 5 boxes for the 5 times as many. All right. So 5 times as many is 7. So 7, 7, 5 times as many as 7, right? So 7 times 5 we know is 35. And again, we want to know how many miles he bikes all together on Sunday. So if he does 7 miles in the morning, so I'm getting that from here, 7 miles in the morning, 35 miles in the afternoon, because again we did 7 times 5, 35 plus 7 is 42. And again, to fill out these types of problems here, we start with our ones place over here, and we put, so that's 242. Then you go ahead and circle the 4 and the 2. All right.